Hi, I'm Paul Brodie. This is my shop. On the other side of the camera is Mitch. He's recording. Thank you. And we're going to work on a fork today. What I have here is basically the evolution of the gator blade. This is the first generation, second and third. So the first generation had a straight crown where the crown is in line with the steer tube and the blades come down and are curved. We made maybe, I'm guessing now, 100 of these. And some collectors really like these because they were the first ones and they're somewhat rare now and hard to find. This is the second generation. It got offset. I did a lot of these crowns myself on the lathe and the mill, and this is a heavier tube and it's got a dropout made out of steel, and the wall thickness down here is 0.9. The last generation, which was the most sophisticated, it had an extrusion for the crown and the blades were a 0.7 mil, which is nice and light, a little bit of flex, and it had the alloy dropout. So in a nutshell, this is the evolution of the gator blade. I know a guy, he's tall, and he wants to use this particular fork on his frame, but the steer tube is too short. So what we're going to do today is extend this. So we're going to make one fork out of two forks. We're going to make a cut here and cut this one off at the right length and join this onto here. Here's the inside of a steer tube. You can see here is the butt. This is the strongest part, and this is going to be from here to here. And then you have the tapered section. So this is going to be a hacksaw cut here, and I want this to be about a little over 1 inch between here and here. And then there's going to be a tube inserted inside. So I've got a tube here, it's chromoly, it's fairly thick wall, 083. We're going to put that tube inside. I'll put a chamfer on this here to make it a little lighter, a little nicer. I'll also put a chamfer here, and that's for the TIG weld, so you get some a penetration going. And that'll be all around the tube. Be TIG welded. There'll be a little bump in the weld. File it smooth, sand it, so if you look at it, you can't even tell it's been extended. I've got a quill tube off a stem, and if I put this down, it stops right there. So if I mark it, see, I've got a mark there, I've got a red felt pen mark. So that tells me where the butt starts, because I have to know that. So if I pull that out, I've made a mark there. So that's where it is. That's where the butt starts internally. And then I want about so much here. That's about an inch, inch and a bit, inch and an eighth. That's where the hacksaw is going to come. And then the insert will go down that far. Now I have to make sure that after the insert comes up here and I put on the steer tube off this fork, a donor fork, I still have room inside the top so that the quill stem can go down far enough, because it would be kind of silly to extend it and not have the quill go down enough. So you have to take all this into consideration. First step is the hacksaw. I'm told the steer tube has to be 8 1/4 inches long. That's its final size, maybe a little shorter, but we're going to make it 8 1/4. And so this is how I find out how long I have to cut it. So this will be the donor. I think we'll go over to the lathe now, and I'll sand off the paint. We'll face the end, put a little chamfer on there. So we'll have to check the size now to make sure there's a little bit of a fit with the tube that goes in. What I'd like ultimately is size on size, where the tube has to be just, or the steer tube has to be hit just very lightly and it goes on. That's the fit that I'm looking for. I mentioned it was 083 wall, and I think it's a couple thou over. Well, it's 1.5 thou over 7/8 of an inch, so that makes it 0.8765. So if I take a telescoping gauge, I'll just hold this in the vise very lightly. So I open it up, I move it over center. Oh, it's quite oversized. It's like 880, 881. So this is gonna, well, actually I think what's happening is it's not round. I must have measured on the large part, because if that was really 5 thou larger, this would fall in. So that's good. That's the kind of fit I want. So I'll take the burrs off this, and then we'll check the ID of this. Okay, that's deburred. Let's see what size this one is. It's smaller than the last one. It's the same size as the tube. It's 1.5 thou over. So that's good. So this is going to work fine, this piece of tubing. So if I cut this at 2.5 inches or 2 3/4, that should be fine. Actually 2.5, or a little bit less than 2.5. I just use the file and I put a little chamfer. It's not an angle like that, it's more like a roundedness, a little bit of a roundedness, so that if the tube is flexing, if the steer tube is flexing, there's no sharp edge that might cause a stress riser. I'm going to set up a boring bar now, and I'm going to put a slight angle on the inside, because it doesn't have to be the 083 right out to the very, very end. Just makes it a little nicer job. I'll do the second side now. This is my sanding stick. Can you see how it's a 1/4 inch rod and it's got a slot made by a hacksaw? What I do is I wrap some emery cloth in there around, and I put it in a hand drill. I want to take the rust out of there, because that could stop that insert from going down. I just made this, and I just used a hand hacksaw in the vise. You can make one of these too. You don't need any fancy tools. Wind this up so that fits inside. There we go. I've got some press lube here. What this does, it helps to stop any scoring going on. If you press a steel insert into steel, sometimes it can gall. It picks up. One metal moves from one piece onto the other, and then it gets really hard to put in. So I'm going to use a little bit of press lube, and I'm going to put it inside. But I'm going to start from about here, because I don't want any of this in the weld area. So I put a little bit on my finger. Don't need much at all. Go inside and just kind of smooth it around. If I use a hammer, I'm going to deform the end. Don't want that, so I'm going to use an aluminum block. And the aluminum is softer than the steel, than the chromoly. So the halfway point is right about there. Let's see how this works. Should just tap in nicely. That was good. That's exactly what I wanted. That's a good press fit. That's about size on size. That's what you call it when they're both the same size, so there's no slop. This should go on pretty easy. Now I want to line up the back. I know this one's a bit looser, so I'm not going to use any press lube here. We're going to do a little TIG welding now. I think what I'm going to do is I'm going to do a little bit on one side, a little bit on the other side. I'll go back and forth around. I won't just start and go all around. I'm going to use a slightly larger rod this time. This is 045. Most of the welding I do on steel frames is 035, so it's 10th thou larger. I tried to make the weld slightly proud so that I got something I can file off and not have any holes afterwards. If you've noticed as well, I don't have the torch at an angle. I've got the tungsten aiming right down, so the heat is going right into the metal. I get lots of penetration. I don't want to just have a surface weld. I want it to go down as far as the inserted tube. Oops. Got a little air bubble happening there. I don't know if there's a bit of dirt. I thought I cleaned everything pretty well. I suppose when I file it up, I'll see if there's anything under there, a little bubble or anything. I think it's okay. I'm just going to use a small file here, and how long can it take? It can't take that long. So always go at a 45. If you go at a 90, it's too easy to gouge. So 45 is good. So you can see I'm only taking off the least amount. Haven't seen any air bubbles yet, so I guess I caught them. Good, so no air holes, no low spots. I don't have to go back to the TIG. I'm going to grab my belt sander, give this a little polish, and then some emery cloth. Invisible welding, that's what I call it. Yeah, that's what I want, where it all looks the same and you don't see the sanding marks from the belt sander. It looks like brand new. And you can't tell that that's been extended unless someone told you. I might have showed you how to align a fork earlier, but I can't remember if I did, so we're going to go through the process here right now. So this is something that when you put the fork in and you close this screw here, it holds it against this face, And then this piece here is 100 millimeters, and so that simulates an axle. Actually, it's not 100 millimeters, it's 95, so you have to have a space on each side. So the actual spacing of the dropout should be 101 millimeters, so it's 1 millimeter larger than the axle, so it always goes on. And the spacing is 101. Can you see how there's a little bit more space here than over here? So I need to pull these blades slightly this way. So I'll give it a little pull. So I'm going to give it a little pull on both of them, just a little pull. A little pull. Just a little pull. It's pretty even. Not way out, and it's at 101, so that's good. So that's the first stage of aligning a fork. The second stage is to make sure that the dropouts, the axle, is in line with the crown. All this is a piece of aluminum. It's an extrusion, and then I have an axle here. And so what I'll do is I'll hold it up into the dropouts. And I'll sight down there. That should be level with this. And according to my eye, that's level. It could be out a few thou, but that's close enough. And the next stage is, I'm going to take off these so that I can see a little better. And I've got a fixture here that got made years ago, and it fits into the axle slots. It's a little bit wider, so see how the fork blades have to spring a little bit, so there's equal pressure, and then you lower this down and it should be equal on each side, and according to my eye that looks good. So that's the third way, or the third part of aligning a fork. And the last step is to align the dropouts. For that we use the Campy tools, and they go in like that, and these might be out a little bit. Not bad though. It is out just a little bit. These faces aren't quite lining up. Can you see how there's a... So what I do, how I align that, I give a little bit of pressure, and it doesn't take that much force because these aren't hugely strong. So there's a little bit of force, and this one needs a little bit too. Maybe a little bit that way. So that as you hold them together, you shouldn't see any daylight there. And that looks good. So those are the 4 ways that you align a fork. That's it for today. It's a shorty. Hope you enjoyed it. See you next week. Stay safe.